What if everything we thought we knew about the beginning of the universe was wrong? What if the cosmic timeline we've spent decades perfecting is actually missing something massive? Right now, the James Webb Space Telescope is staring into the abyss of deep time. And what it's finding there is making cosmologists lose sleep. Because buried in the darkness of the early universe, Webb has detected something that shouldn't exist. Four ancient galaxies, so impossibly old, so ridiculously massive, they're forcing scientists to question whether our entire model of reality needs to be thrown out and rebuilt from scratch. Let's be clear about what we're dealing with here. For nearly a century, astronomers have operated under one fundamental assumption. The universe began with the Big Bang, approximately 13.8 billion years ago. Everything we see, everything we measure, everything we predict flows from that single moment. The math works, the observations fit, the model holds together like a perfectly constructed machine. But machines break, and right now, Webb is holding the wrench that might shatter the whole thing. Here's how we map the universe. When astronomers look at distant galaxies, they measure something called redshift. Think of it like this. As the universe expands, light from faraway objects gets stretched like a rubber band, shifting toward the red end of the spectrum. The more stretched the light, the farther away the galaxy, and crucially, the further back in time we're seeing it. It's not just distance we're measuring, it's history itself. For decades, Hubble gave us glimpses into this ancient past. It found galaxies billions of years old, pushed the boundaries, revealed cosmic wonders. One of its crown jewels was GNZ11, a galaxy that formed just 400 million years after the Big Bang. At a redshift of nearly 11, it was considered one of the earliest structures ever detected. Astronomers celebrated. The model held firm. Beyond redshift 11, they believed, there would be almost nothing. The universe simply hadn't had time to build galaxies yet. Then, Webb opened its golden eye. Unlike Hubble, which struggles with infrared light, Webb was engineered specifically to pierce through the infrared veil that hides the earliest epochs of cosmic history. And when it finally turned its gaze toward those forbidden depths, the universe didn't whisper its secrets, it screamed them. Dozens of galaxies, hundreds of millions of years earlier than expected. Bright, massive, structured galaxies that had no business existing when they did. NASA's initial surveys revealed galaxy candidates forming just 200 to 300 million years after the Big Bang. Then came Glass Z13, detected at a redshift of 13.2, suggesting it formed a mere 300 million years after creation itself. But that was just the beginning. The Mir European Consortium was scanning Webb's data for faint, overlooked objects when they stumbled across something extraordinary. An exceptionally red, dim object that previous surveys had completely missed. At first, they thought it might be a nearby dwarf galaxy obscured by dust. Further analysis crushed that theory. Could it be a distant, dusty galaxy from a few billion years after the Big Bang? That didn't fit either. The third explanation is the one keeping astronomers up at night. This object appears to sit at a redshift of 15. If that's correct, it existed just 100 million years after the Big Bang. 100 million years. In cosmic terms, that's an eye blink. That's not enough time for anything this massive and luminous to form under the rules we thought governed reality. And it's not alone. Webb has now identified what scientists are calling little red dot galaxies. Tiny, incredibly dense, impossibly bright. They're far more massive than current models predict they should be. Some contain more stars than the entire Milky Way, yet they formed barely 800 million years after the universe began. That's a problem, a massive, universe-shaking problem. Here's why. According to the standard cosmological model, galaxies don't just appear out of nowhere, they need scaffolding. That scaffolding is dark matter, the invisible gravitational glue that clumps together to form halos, where normal matter can accumulate and eventually ignite into stars. This process takes time, a lot of time, more time than 100 million years. But these galaxies, they don't seem to care about the rules. Claudia Lagos, an associate professor of astronomy, put it bluntly. The existence of these extremely massive early galaxies poses serious challenges to everything we understand about cosmic evolution. The dark matter structures needed to anchor them simply wouldn't have existed yet. They couldn't have formed this early. And yet, here they are, staring back at us through 13 billion years of space and time, daring us to explain them. So how do we explain the impossible? Some scientists are proposing radical ideas. Maybe galaxy formation doesn't require dark matter halos the way we thought. Maybe there are alternate pathways, different mechanisms we've never considered. Maybe the early universe was fundamentally different than we imagined, operating under conditions so extreme they allowed matter to condense and ignite faster than physics should permit. Others are going even further. To truly understand these galaxies, some cosmologists argue, we might need to look beyond the Big Bang itself. What if the Big Bang wasn't the beginning? What if it was a transition, a phase change from something that came before? Nobel laureate Roger Penrose has championed one of the most mind-bending theories in modern cosmology, conformal cyclic cosmology. In his model, the universe undergoes infinite cycles of birth, expansion, death, and rebirth. What we call the Big Bang might just be the latest iteration in an eternal sequence. The massive galaxies Webb is finding could carry imprints from a previous universe, echoes of a reality that existed before time as we know it began. It sounds like science fiction, but when the observations don't match the theory, you don't ignore the observations. You change the theory. And that's exactly what's happening right now. The standard cosmological model, the framework that's guided astronomy for generations, is being stress-tested like never before. Every new Webb observation adds another crack to the foundation. Every ancient galaxy is another piece of evidence that something fundamental is missing from our understanding. Some researchers are exploring multiverse theories, suggesting our universe is one bubble in an infinite foam of parallel realities. Others are revisiting cyclical models, where the cosmos breathes in and out across unfathomable timescales. Still others are questioning whether dark matter behaves the way we think it does, or whether entirely new physics is required to explain what we're seeing. The stakes couldn't be higher. This isn't just about a few galaxies that formed earlier than expected. This is about the origin of everything, the nature of time, the rules that govern existence itself. Webb is now entering its most critical phase of operation. With each passing month, it's pushing deeper into the cosmic dark, hunting for objects that challenge, confound, and ultimately enlighten us. Scientists are preparing for discoveries that could completely rewrite our cosmic origin story, revelations that might finally answer the oldest questions humanity has ever asked. Why does the universe exist? How did it begin? And what, if anything, came before? The answers are out there, hidden in the light of galaxies so ancient they shouldn't exist, and the James Webb Space Telescope is bringing them home.